Our new topic is on remainder and factor theorems. On this session, you will learn how to state and illustrate the remainder and factor theorems, use synthetic division and the remainder theorem to find P of C when x is equal to C, and determine whether a binomial x minus C is a factor of the polynomial function P of x by applying the factor theorem. Now let's start. In the previous lesson, you have learned how to divide polynomials using long division or by synthetic division. So let us try to use synthetic division for us to divide the polynomial function p of x equals x cubed minus 2x squared plus x minus 3 by x minus 2. So for the first step, we're going to write the coefficients of the p of x, and that will give us 1, negative 2, 1, negative 3. And then we're going to write the constant c of the divisor in the semi-box on the left of the first row, and that is positive 2. And then we bring down the first coefficient 1, 1 times 2, and that will give us 2. And then we add negative 2 plus 2, and that is 0. Then we're going to multiply 0 by the constant c of the divisor, and that is 0 times 2. That is 0. 1 plus 0 is 1. And then multiplying again 1 by 2. That will give us 2. Negative 3 plus 2. That will give us negative 1. Now, since the divisor is x minus 2, let us try to evaluate p of x at x equals 2. So, on this case, we're going to substitute all the values of x into positive 2. And that will give us 2 cubed minus 2 times 2 squared plus 2 minus 3. Simplifying, we have 8 minus 8 plus 2 minus 3. Performing the operations, we have p of 2 equals negative 1. So notice that when the function is divided by x minus 2, the remainder is negative 1. And when the function is evaluated at x equals 2, the result is also negative 1. And this will lead us to remainder theorem. The remainder theorem states that if a polynomial function p of x is divided by the binomial x minus c, then the remainder is equal to p of c. So based from the solutions above, we can say that the remainder is equal to the value of the p of c. Let us deal with the first example. Find the remainder when x cubed plus 2x squared minus 5x plus 2 is divided by x plus 3. So all we need to do is to substitute the value of x into negative 3. So we have p of negative 3 equals negative 3 cubed plus 2 times negative 3 squared minus 5 times negative 3 plus 2. So in here, we need to evaluate negative 3 cubed. The answer is negative 27. Then we evaluate here the negative 3 squared, which is 9. Negative 5 times negative 3 is 15. Bring down positive 2. Simplifying 2 times 9, there we have 18. Performing the indicator operation, negative 27 plus 18 plus 15 plus 2. So the value of p of negative 3 is equal to 8. So it means, using the remainder theorem, the remainder when the x cubed plus 2x squared minus 5x plus 2 is divided by x plus 3 is equal to 8. Let us deal with the second example. Use remainder theorem to find the remainder when x cubed plus 4x squared plus x minus 6 is divided by x plus 2. So in here, we need to substitute all the values of x into negative 2. Evaluating p of negative 2, we have negative 2 cubed plus 4 times negative 2 squared plus negative 2 minus 6. So evaluating negative 2 cubed, which is negative 8, negative 2 squared, which is 4, bring down negative 2 and negative 6. So in here, we need to multiply 4 times 4. So we have here 16. So performing the indicated operations, we have negative 8 plus 16 minus 2 minus 6. So the answer, P of negative 2 is equal to 0. So it means the remainder is equal to 0. Referring to the second example, when a polynomial is divided by x minus c, if the remainder is 0, we say that x minus c is a factor of the polynomial. Through the remainder theorem, we now know that the remainder is related to the evaluation of the polynomial. So, in here, we are led to the conclusion of factor theorem. So, the factor theorem states that if p of c is equal to 0, then x minus c is a factor of p of x. Conversely, if x minus c is a factor of p of x, then p of c is equal to 0. For example number 3, let us determine whether or not x plus 2 is a factor of x cubed minus 2x squared minus 5x plus 6. By substituting the value of x into negative 2, we have p of negative 2 equals negative 2 cubed minus 2 times negative 2 squared minus 5 times negative 2 plus 6. Simplifying, we have negative 2 cubed is negative 8. Negative 2 squared is 4. Negative 5 times negative 2 is positive 10. And then we bring down positive 6. Simplifying 2 times 4, we have negative 8. So we then have negative 8 minus 8 plus 10 plus 16. So the value of p of negative 2 is equal to 0. So it means that the remainder is equal to 0. Since the remainder is 0, we can then say that x plus 2 is a factor of the polynomial x cubed minus 2x squared minus 5x plus 6. Moving on with the fourth example, find k so that x plus 5 is a factor of the polynomial x cubed plus 5x squared minus kx minus 20. Since x plus 5 is a factor of the given polynomial, we know that the remainder is 0. So we can solve that by substituting all the values of x into negative 5 and setting the left side of the equation be equal to 0. So we have 0 equals negative 5 cubed plus 5 times negative 5 squared minus k times negative 5 minus 20. Simplifying, negative 5 cubed is negative 125, negative 5 squared is 25, negative k times negative 5 is 5k, and then we bring down negative 20. Then simplifying 5 times 25, we have 125. So we now have 0 equals negative 125 plus 25 plus 5k minus 20. Negative 125 plus 125 is 0. So we have now the result of 0 equals 5k minus 20. Solving for the value of k, we transfer it to the right side, to the left side of the equation rather. So we have 5k equals 20. And then we divide both sides by positive 5. So the value of k is equal to 4. So that x plus 5 is a factor of x cubed plus 5x squared minus kx minus 20. The value of k is equal to 4. Let us deal with example number 5. Find another factor of x cubed minus x squared minus 4x plus 4 if x minus 1 is a factor. So for us to solve this, we will be using synthetic division. Placing all the coefficients of the polynomial, we have 1, negative 1, negative 4, positive 4. And then placing the coefficient of the divisor, on the upper left box, we have 1. And then for the first step, we're going to bring down the first coefficient 1. 1 times 1 is 1. Negative 1 plus 1 is 0. 0 times 1 is 0. Negative 4 plus 0 is negative 4. Negative 4 times negative 1 is negative 4. And 4 plus negative 4 is 0. And then we're going to write the quotient. So the quotient is x squared minus 4. So therefore, another factor of x cubed minus x squared minus 4x plus 4 is x squared minus 4. Now, let us try to do this. What is the remainder if x squared minus 7x minus 4 is divided by x minus 2? Is it A 4, B negative 14, C 2, or D negative 2? Moving on, which is the remainder if 2x cubed plus 4x squared minus x plus 7 is divided by x minus 2? Is it A 35, B 36, C 37, or D 38? For the next one, is x minus 3 a factor of x to the fourth minus 3x cubed minus x plus 3? Is it A false, B true, C uncertain, or D invalid? Moving on, which of the following is a factor of x cubed plus 5x squared minus x minus 5? Is it A, x plus 2, B, x plus 5, C, x minus 5, or D, none of this? I hope that you learned something from this lesson. Until our next session, thank you and enjoy learning.